Now the next one, up to the next one, on to the next one. We have question 13. The luminous intensity I candelas of a lamp is varying at varying voltage. V is 1 equals 4 times 10 raised by negative 4 square. V square, Determine the voltage at which the light is increasing at the rate of 0.6 candelas per volt. At the rate of 0.6 candela per volt. This was just like what we did the other time, right? So what we need to do, we want to get the rate, just like what we did before. They already gave us an expression, and the expression is what they give us, that this is the guy here. This is the guy here. Are we together here now? So with that guy they give us there, what we need to do is just for we to actually differentiate this. But then, just like what I said before, it's something we want to find the dIdV first. Differentiating I with respect to voltage. Are we together now? And they said, okay, find the rate. You know how to reach about that, but let's differentiate that first. Now, differentiating that will be V square. I told you that the whole of 4 times 10 raised power minus 2. I told you that is just a constant. So differentiate V square. V square is 2V. So 2 times 4, 8. That's how we got this here. So 4 times 10 raised power minus 4. Let that be a constant, then differentiate V square. Differentiation of V square is what? 2V. 2 times 4, 8. That's how we get 8 times 10 raised power minus 4 voltage. Now set the derivative equal to the given rate. That's it. They already gave us a rate. You want to know, don't forget, they already gave us a rate. What's the rate they gave us? They gave us a rate of 0.6. They now said at what voltage? You want to get the voltage that will bet that. You want to get the voltage that will bet that. You want to get the voltage that will bet this. So differentiate what we get the derivative here, set it equal to rate, because we've gotten the rate already. What we did here was the rate. What we did here before the rate with respect to V, IV. So we've gotten the rate. Now the rate we got here was in terms of V, but they said that rate itself has a definite value at a point. That will be 0.6. So we want to know that value of that voltage at that point. That's all. Do you understand? So set what we get the derivative we got equals to the rate they give us. Rate and derivative, they are the same thing. So next, and then continue. So we already gave us, we told you that what do you need to do? Just set it, right? So we set this one equal to this. Then the next thing you divide both sides by 8 times 10 raised to minus 4. Obviously, you know that. Now, 8 times 10 raised to minus 4. 8 times 10 raised to minus 4. So that will be 0.6 over, when you divide both sides by that, divide this one by 8 times 10 raised to minus 4, and divide this one by 8 times 10 raised to minus 4. You know 8 times 10 raised to minus 4, we cancel this. Then we are left with V equals 0.6 times 8 times 10 raised to minus 4. And 0.6, changing it from standard form to decimal, is going to be 0.0000 and 8. So that will be 10 raised to minus 1, minus 2, minus 3, minus 4. That's how we got that. So dividing it to get 750. So 750 volts will be equal to, we give us something at that rate with the equation we were provided with. The next one we have here, let's go to the question again. You know, I like doing that so that you see what I'm doing, just the way I'm doing it. Air is pumped, number 13. Air is pumped into a spherical balloon so that the volume increase. We are talking about volume here. At the rate of what? They give us a rate. How fast will the radius of the balloon increase when the diameter is 50? They give us a rate which will leave the answer in terms of pi. Now, we are talking about volume. What's the formula for the volume of the square? 4/3 pi r cube. That's the formula for the volume of the cube, of this thing. Don't forget, just like what we did, I think question, what now, forgotten, when we get, I told you that we use chain rule, that dV dt, they gave us the rate. dV dt is going to be what? dV dr times the r dt. Don't forget, when we're doing area of this, and when we're talking about circular stuff, don't forget. Now, what's the volume here? Volume is 4/3 pi r cube, and we know the rate dV dt is actually dV dr times dr dt. So what's our dV dr? Differentiating this one, and 4/3 pi will be a constant that we are accompanying our integration. So that will be 4/3 pi times integration of r cube is what? 3r squared. This one cancels this. That's how we get 4 pi r square. Then the dr dt. But they gave us the diameter to be 50. Don't forget, diameter is 2 radius. Diameter is 2 radius. So to get the radius divided by 2. So that will be 50 divided by 2, we get 25. And they've given us our dvdt to be 100 centimeter cube per second. All we need to do is just simple to get the rate at which the radius is increasing if the volume is increasing at that point. So we need to make the r dt subject, and then from there we get the relation. Remind me, so this is where we are, this is where we are, this is where we are, remind me. Now, we are here already. So we said dividing this one by 2 because they gave us the diameter, we divided it by 2. And we already had the dvdt, so substitute it into what we have around here. Put dvdt equals 100, put radius equals 25, and we want to get the rdt. They said we should leave our answer in terms of pi, don't forget. So that will be 100 equals 4 pi times 25 squared, because it is r squared here. So 25 squared, that's 625. 4 times 625, that's 2,500 pi. So the rdt will be dividing both sides by 2,500 pi, 2,500 pi. So that will be 100 over 2,500 pi. So this 0 cancel 0, 0 cancel 0. We have what? 1 over 25 pi centimeter per second. That is the rate at which the radius is increasing. That's the rate at which the radius is increasing. Now the next one here, next stop is this. Let's go and see the question again. That's number 15. I guess almost true now. Now evaluate the dt correct to the what? To 3 significant figure at when t equals pi over 6 for s equals 3 sin t minus 3 plus root t. 3 sin t minus 3 plus root t. Now what do we want to do? We want to evaluate that. We want to get the derivative. So we differentiate this one by one. So we did it in PS. We don't want to get to stress yourself at all. Differentiating 3 sin t. 3 will be a constant. Then differentiating sin t. Sin is what? Cos. That's how we get the 3 cos t. Differentiation of a constant is 0, so minus 3 is 0. Differentiation of t square. Root t. That will be 2 raised to power 1 over 2. And you know the rule of differentiation. Now you bring this one half. Bring it down first. Right? Then the t half plus 1 from nominal rule. So this is going to be 1 over 2 t. Half plus 1 is 3 over 2. Half plus 1 is 3 over 2. Half plus 1 is 3 over 2. I guess I made an error around here. Oh, I'm sorry. Oh, it's not plus 1. I guess I was the one saying nonsense. So this is the next one we want to do now. And the question is there. The question is here. Oh, sorry. I guess you get to view it yourself. The question. Now I'm sorry, couldn't fetch it. Now this is the last question, number 15, in the last year past exam. So we have integrate. We want to differentiate 3 sin t minus 3 plus root t. Now we did it in PS. What is the differentiation of 3 sin t? Let 3 be a constant, then differentiation of sin t is cos t. That's how we got this. Differentiation of minus 3. Differentiation of a constant is 0. That's how we got 0. Now differentiation of root t. Root t is the same as t raised to power half. And the rule of differentiation is that when you have s raised to power n, then that will be n s nominal rule n x n minus 1. So my x is t, my n is half. So that will be half t half minus 1. Half minus 1. I have a whole 1. You remove half. So that will be minus half because actually 1 is greater than that. Or you can know your fraction. So we get 1 over 2 t raised to power minus half. And by the rule of indices, that's the same as 1 over 2 t raised to power what? T raised to power 1 over t raised to power half. And t raised to power half is root t. So that's where we get our 1 over 2 root t from. So joining the two, that's where we get the ds dt at this point. The ds dt here at that point. So this one is already 0. We join this one to this. That's how we get this here. But they gave us a point in t. They gave us a point pi over 6. Pi over 6. So we are taking it one by one. We don't want to get to stress yourself at all. So substituting t equals pi over 6 for t here. So that will be 3 cos pi over 6. Pi over 6. What is pi? Pi angle wise is 180. Note that please. But number wise, angle wise is 180 degree. Number wise 22 over 7 or 3.142. Angle wise, if it is serving angle 180. If it is serving as a number, like in this situation now, it will be serving as a number. In this situation, it will be serving as a number. In this situation here. But in this other one, it's serving as an angle because it cos t. T there is an angle. So in that situation, pi over 6, that's what do we say? 180 over 6. 180 over 6 is 30. Cos 30 is what? Root 3 over 2. That's how we got all we have here. Do we understand at all? Thank you. Now let's continue. Now to continue with this, what do we do? Now we already told you what our two guys would be. The first one we said that would be root 3 cos pi over 6 is root 3 over 2. And the other one we have half root. You know we have 1 over 2 root x. Root t. What is our t? Pi over 6. So we can say that will be the same as 1 over 2 times 1 over root 2. Rule of multiplication. So 2 times root 2 is 2 root 2. So that will be 1 over 2 times 1 over root what? They said we should use pi over 6. Are we here? And by the rule of third, this is the same as 1 over 2 now times 1 over root pi over root 6. Now this thing we don't like 3 steps, so you'd rather make it 1 divided by this, and at the end of the day you bring this one up, you bring this one down. And that's how we got it here. Now together here now, and then pi in that situation, I told you what pi is having. I told you pi number was is having 3.142, and the square root of 3.142 is approximately what? 1.772. Root 3 is approximately 1.732, and root 6 is approximately 2.449. Then joining everything, so 3 times 1.732 over 2, we get 3 times 0. Simplifying this side, we get 3 times 0.866, and that's the answer there. 1 over 2 times 2 points, just simplifying, we get what we got. Now almost the end. So this one here is to be plus, let me write it in another ink, I guess there's no time, 0.691. So we added these two, and by approximation we get 3.29. 3.29 is the answer for that question. Approximately 3.29 to the nearest 3 significant figure. Thank you very much for staying to the end of this show. I hope you enjoy it. Please, I will drop my number at the end of this show, or let me even drop my number around here in case you have an issue at any point. I'm equally a UI student, a 400 level UI student at that. So you can always talk to me anytime. Your success is what is so important to me. I want to see people get first class in mathematics. I want to see people get 4 points. You want to 4 point this course. You don't want to make mistake here, because 4 unit course, they actually send them. So in case you have an issue at any point at all, or there's another thing bothering you, you're 101, you are like, I don't understand math at all, we still have like from this week, next week, I think 2-3 weeks or 2 weeks or so to your exam. You can always talk to me. So to talk to me, my number is 081-311-59713. To talk to me, that's call number. So once you call me, I'll be able to drop a message for you on WhatsApp. The WhatsApp number is kind of funny, half forgotten, I'm sorry. I have a lot of things on my mind. So that is it. You can always call me via this number, and the name is Emancipator, a 400 level mathematics student who is so interested in people making it without disturbing themselves. Going through it alone can always be boring. When you have the help and assistance of somebody that already knows the road, of course, it's going to be easy. And together, we can achieve the desired success. Thanks for staying through this thing. I hope it was so resourceful. Thank you very much.